All right, so with that, let's get going. I think that there were a number of presentations that I listened today where folks talked about different tools and how they're using ONNX and things. And that's what I'm here to talk about as well, but a little bit different. I'm not going to go into the models. I'm not going to show you any tools. I'm just going to talk to you in general what we're using ONNX for and how do we collaborate with community. Does that make sense? Okay. In case if you don't know, Qualcomm makes chips. We can't give chips away as they are. We have to give software to actually make them work. So, and the chips that we make, the SoCs that we build and devices that we support, they range from itty-bitty tiny earbuds to the mobile phones, to the XR glasses, to automobile equipment, laptops, secure cameras, and things like that. And one of the things that hopefully you guys are going to take away is if you come to us with a model and you're using ONNX as an interchange format, you can actually target your model and use it on all of the devices that we support and enable. So how do we do that? Very easily. First of all, if I look at what our customers and development community has to deal with, is first of all, there are a ton of different devices that are being built. Some of them, as I said, really small, really tiny footprint, itty-bitty power consumption that they can afford, to something that takes about 2 watts or less, to about 5-watt device, which is what our laptops are, plus minus, depending on how power hungry your computer is. And I know some of the folks here from competitive companies and their SoCs are a little bit power hungrier than what we make, but nevertheless, to the automotive systems where you have a lot of compute that's necessary with a lot of cameras and a lot of other things that consumes a lot of power. And even further than that. The next thing that we have to deal with, is the challenging architectures. Because we have to support all of these different devices, we have folks that come to us with a little bitty, itty-bitty, tiny noise cancellation algorithms that have to fit into, I don't know, 100K of memory, to folks that use devices that have to go and navigate and drive a vehicle. So they have a much more complicated models, much more data that they have to process. They have a plethora of cameras that at the same time taking images and have to figure out how to drive a car without hitting pedestrians and things like that. And the models are different, the implementations are different, requirements and timing requirements are different. Lastly, the desired features. Believe it or not, but we have customers that come to us and say, you know what, we built this model and it runs on this device, but it's not enough for us because we want to run the same device or the same model on a different configuration. And the best example I can give you is, how many folks still remember that it burned into my eyes, that Apple commercial with a guy dancing in the market, buying things with his face detection. Anybody remembers that commercial? Apple used to play it like non-stop on TV. So 4 years ago, plus minus, Apple built into the iPhones the depth sensor. And what they did with the depth sensor is they said, you know what? We integrate a camera with a depth, and using these two things, we have an unbreakable 3D face authentication. And you can use it to actually buy things using your cell phone, right? Your children won't be able to buy it. Nobody else can buy it. Only the payment system will recognize you as your face. And because they're using depth and a camera, they can make sure that it's not a picture of you and other things, and unbroken authentication path. That was 3-4 years ago in mobile phones. Next thing you know is you have the same exact algorithm, same exact capability, but now folks want to use it in a secure cameras where you walk up to your home, you already have probably like a smart doorknob or a ring, one of those things. They recognize you, they look at you, they use exactly the same model, exactly the same thing. Authenticate it's you, open the door for you. You can get in to your house, okay? Move the time to today's dates. There are plethora of cameras these days inside automobile, right? And outside. So what they can do is the automotive guys now come to us and say, we want to use exactly the same algorithm, exactly the same technology. All these things that you already certified for payments and certified for processing and unlocking your phones, now we want to have it in a car. So when you walk up to your car, the car recognizes you, opens the door, you sit inside your vehicle, they'll see that you're licensed and authorized driver using exactly the same algorithm. Nothing changed, nothing modified, same exact model, same exact train material and everything else. Now they look at you, they recognize that you is you are an authorized driver, and in addition to that, sometimes they even look at you, make sure you're not distracted or drunk or things like that, and then they'll let you start the car and drive off the vehicle. So scalability. So that's kind of the last challenge that we have to deal with. Thank you. So the way we've done it at Qualcomm is, and I know there are folks that talked about how you can process machine algorithms on the CPUs. Good for you. And I've heard other folks talked about GPU and how fast this GPU is and how awesome it is that they can get better processing. The way we'll look at it is, if I take a model, I don't know, Inception v3, maybe something like that, and I can run on a CPU on a decent frame, so the decent resolution, I can probably get about, I don't know, 5 frames per second, inferences a second on a good day, right? So you give me a picture, 5 times a second, I can look at the picture and tell you there's a dog in that picture, okay? If I take this exact algorithm and its model, it's got converted to ONNX RT, to ONNX, and then you're running on a CPU. I take this model, I removed it and said, I want to run on a GPU. Much faster. How much faster? I might get about 30, 40 inferences a second, which is borderline useful because now, instead of processing a picture at the time, I can do inferencing on a live video stream. Maybe it's not 60 frames per second at a good camera, but 30 frames per second I can probably deal with. Now, if I take this exact algorithm and move it off to the AI accelerators that we have in Qualcomm devices, and from other vendors, they have their own, I can probably get, I'm talking about on a range of 1,000 inferences a second. So not only I freed up CPU to do something useful, not only I let my GPU to deal with dealing with displays and resolutions and doing the GPU kind of stuff, now I'm using AI on this specific for-purpose built AI accelerator that barely consumes any power and is much, much faster. And the way we scale is we take this exact architecture and we make it multi-core, if you're talking about like automotive kind of equipment. And if you want to go into the cloud and do inferencing at the edge, we have devices where we stack up a whole bunch of these AI accelerators, parallelize them, and then we can do kind of cloud level workloads on that. And that's how we scale our hardware. But scaling hardware is not good enough. To deal with that, you have to actually scale software as well. And these are just few things that I had pictures in my slide deck. I was asked to actually put bullets. So bear with me. First of all, we have customers that come to us from all over the place. And the benefit of them using ONNX as an interchange format is because they can go from whatever training framework they use to ONNX, and then we can have it translated and compiled directly to execute on our hardware. And when I say on the hardware, I mean that we can take this ONNX model and hook up a backend for it and conversion to the CPU, to the GPU, or to our AI accelerators. You don't have to change the model. We will handle all the translations and all of the compilations behind the back. Well, I already covered the second bullet point, the direct conversions. And that helps them to scale. It helps them to scale across the capabilities of device. The same ONNX model can run on a small device, more powerful device, more capable device. And it also helps to scale across the verticals. Like I said, you build things for mobile phone, and then you can use the same model on a smart camera, and then you can use the same model in a cloud. Now, to us, and that's something that we talked about during the lunch, it saves a lot of time to Qualcomm. Because instead of me having a paddle-paddle converter and accelerators and be able to accelerate that, and all other frameworks from other regions and geographies, I just have an ONNX converter that takes ONNX interchange format and compiles it into a binary that executes on the device. That's it. I just need to have one, rather than dealing with all these other frameworks one at a time. And lastly, there are folks that come to Qualcomm from kind of two different paths. Some of them come to us and they said, here's the model. I want to get it to the ONNX, use it as an interchange format, and then use Qualcomm software stack to accelerate it on device. A lot of those are folks that built for-purpose devices. They know what they're looking for. They know exactly how they want to partition their models and how to set up system parameters and CPU power and everything else. Then we have a second type of customers that come to us and say, you know what? I just have a model and I want to run it on as many devices as possible. I don't want to go and worry about specific Qualcomm hardware. I don't want to worry about other things. So to them, if they use ONNX RT, then that will kind of protect them and allow them for this portability. So one of the things we're doing right now is we're working with Microsoft on ONNX RT Execution Provider for our AI accelerator. Again, not CPU, not GPU, but specific AI accelerators that the ONNX RT will directly delegate to. Next slide. Again, to Qualcomm, the way we solve it is we put together a unified software stack that allows you to scale across the verticals and across the tiers and complexity of these devices. And how do we do it? Very simple. First of all, we have to support, and I don't know how about other vendors that talked about before, a plethora of operating systems. I don't know if you guys recognize some of them. Anybody has their preferred operating system for devices? So if it's a mobile device, it's obviously Android. If it's an automotive device, things are a little bit trickier, like QNX and others. So depending on the type of device you're using, we have to support that operating system, including even Windows. So the folks that haven't used it, I have right there. For the last 2 years, I used Windows on ARM device from Microsoft. Extremely happy. Lasts me a day or more. Dealing with system interfaces and drivers and support, kind of hiding all the underlying hardware and OS details from you. And then what we've done at the top is we have a unified software library that Qualcomm put together, Qualcomm AI Engine Direct. And the reason we call it AI Engine and not CPU or GPU or a Hexagon AI accelerator is because when you come to us with an ONNX model, we will take care of routing it to one of those things. We can dynamically change it. If you are playing a game, we don't want your AI algorithm to use GPU. We want to offload it to something else. If you're not playing the game, if you're using your phone and just talking, well, gee, when you're talking on the phone, what's GPU doing? Usually it's off, display's off. It detects that it's next to the ear and turns off display. So we can take your AI model and push it to the GPU since it's sitting there doing nothing. And then on top of it, again, as I said, we take ONNX runtime and we're providing a delegation to it. That way, we can take your model and get it the best performance that you guys deserve when you're using Qualcomm hardware. Frameworks we have to support, obviously. That's kind of how our software stack looks like. And then the rest of the tools, I don't have time, but I would love for you guys to come to me and tell me, what do you use today for tools? We have profilers, we have compilers, we have analyzers, we have enablement for the NAS tools, network architecture search tools. If you want to build your model from scratch, go for it. If you want to go and quantize it, we have a ton of tools that helps you to quantize. I didn't know the experience of the audience, and I don't want to spend your time talking about all the intricacies of int4 support versus int8 versus FP16 or int16 and how much data throughput and power it saves. But if you would like to, I'll be more than happy to send me a note, and I'll be more than happy to take your questions and answer those questions about the tools or the underlying technologies. With that, again, hopefully some of the things I explain and how we're looking at the software stack that we put together will kind of answer some of the questions from the audience. It's like, okay, so how do we actually deal with scalability and using ONNX to give customers ability to kind of write their algorithm once, convert it to the ONNX interchange format, and then run it everywhere. Whatever you're using, camera algorithms or building something for connectivity for either camera or XR or compute. Requirements are different. Things that people do on XR device that is battery operated, has 2 displays in front of your eyes, and has to deal with a lot of concurrencies. Very, very different than things that you're doing in a smart camera or smart speaker. Use cases, again, the smart speaker probably has a ton of models, but they're all audio-based, translation, transcription, things like that, versus XR glasses where a lot of it is imaging and be able to deal with computer vision and things like that. And that is my last slide. Thank you very much for giving me a chance to talk to you guys. If you have any questions, feel free to find me in the hallway and I'll be more than happy to answer them.